Hi everybody, so this question was asked to do for a video solution. So this is chapter 24, problem 10. Alright, so let's try this out. And this is going to be a little bit different from my homework solutions because my homework solutions I screwed up. And honestly, my homework solutions are probably more complex than I'm going to show you here. Anyway, so it says a long wire carrying a 5 amp current is perpendicular to the xy plane, intersects in the x-axis at x equals -2 centimeters. And then a second parallel wire is at a 3 amp current, intersects the x-axis at 2 centimeters. And it says, at what point or points on the x-axis is the magnetic field 0 if A, the two currents are in the same direction, and B, the two currents are in opposite directions. So, okay. So we're going to find out where, the magnetic field. So let's see. So here we go. I drew it here. So XY plane looks like this. So up is X, and then to the right is, up is positive Y, and then to the right is positive X. So that's the plane, and they're saying that these currents intersect that plane. And so they start with the two currents going in the same direction. That's with part A. So I got them both going into the page. So the currents are going into the page at 5 amps on my left side. And then on the right side here, it's going to be current 2 that's at 3 amps also going into the page. So that'd be intersecting the page. That's what makes this diagram a little bit more simple. And then here's my x-axis. This is x equals 0. So to the right, that's going to be positive 2 centimeters, like they say right here. And that's the 3 amp current. And then to the left here is -2 centimeters. That's my 5 amp current. All right. And so to get just a sense of where the magnetic fields would point, using my right-hand rule for 2, the magnetic field points around like that. And then the magnetic field points around like this for current 1. So basically, where I'm going to have these two magnetic fields intersecting are going to be in between somewhere. And the place in between where they're going to intersect would probably be closer to the 5 amp current because this is due to the fact that the magnetic field in a wire is mu naught I over 2 pi r. So the bigger the current, the less distance you need in order to get the same magnetic field. That's kind of the big idea there. Okay, so we're trying to find, so I think I'm going to find a spot probably around here. I'm just going to randomly make that X, that point, or I'll make it a dot, and then I'll call this distance X. So this is a distance X. Right there, because that's what they want us to find. They want me to find at what point on the x-axis am I going to find this. So it's a distance X there. Obviously, it's negative. Okay. So, yes, okay. So now, in order to do this, I know that basically I'm going to have I'm going to have the magnetic field pointing up. That's going to be due to current 2. So this is the magnetic field due to current 2, and this would be the magnetic field due to current 1. Using those same things that I used before. If I use my right-hand rule, I can see that current 1 is going to create a magnetic field pointing down because it loops around like this, like that. And then current 2 loops around like this, so it's going to create a magnetic field up. And there you, I'm already realizing I put this in the wrong position. Sorry. I'd want to be closer to this one because it has less current. My mistake. I apologize. So hope I didn't throw you for a loop there. So this is going to be now X. Like that. So let me do this again. So magnetic field due to 2 is going to point like this. And then the magnetic field due to 1 is going to point like this. And now I know these magnetic fields have to be equal in order for them to be balanced. So I'm going to say magnetic field due to 1 is equal to the magnetic field due to 2. And then, so I can use then this equation here. Whoops. I can use this equation here to kind of go, okay, this is going to be mu naught times current 1 divided by 2 pi r1. And this is going to be mu naught current 2 divided by 2 pi r2. And what's nice here is mu naught cancels out, 2 pi cancels out. So none of those things really matter here. But what does matter, and I know I1 is 5 amps, I2 is 3 amps, so I really just need to find out what R1 and R2 is. So to get R1, that's going to be this distance here. Well, that distance, if this is x and this is 2 centimeters, so that distance then, so R1 must be 2 plus x. And then I'll do the same thing for R2. Well, R2 is, this is 2, and this is x, so it must be 2 minus x. And I'll then plug all this stuff in. So I1 is 5 over 2 plus x equals, and then I2 is 3 over 2 minus x. Let's see, cross multiply, I'll get 5 times 2 minus x equals 3 times 2 plus x. Sorry, my setup for the... So just a little algebra now. I need to distribute this 5, and I need to distribute the 3. So it's going to give me 10 minus 5x equals 6 plus 3x. Rearranging this, subtracting both sides by 6, I get 4 equals, and then adding 5x to both sides, I get 8x. Divide both sides by 8, I get 4 over 8 equals x, which is 0.5 meters. So 0.5 meters, that's where I'm going to get the first one. All right, let's go to the next one. Same situation applies, but now they're pointing in opposite directions. So I don't think it matter. The two currents are in the same direction, and the two currents are in opposite directions. Okay, so now they're in opposite directions. So basically, I'll have a loop. If I use my right-hand rule, it's going like this. And then that's for B1. And then for B2, it's going like this. So I can see in between here, I'm basically getting the magnetic field is only pointing up. Like there's no other way to do it. They're always going to add together. To the left of this here, I'll have the magnetic field pointing down, and then I'll have the magnetic from this one pointing up. But this current is too weak and the distance is too far. It's never going to be able to make it to 0. So the only other option I have is over here on this side, where the magnetic field due to current 2 is pointing down, and then the magnetic field due to current 1 is pointing up. But the current is big enough that it might be able to compensate for it. So let's see if that is able to happen. So magnetic field due to 2 would be pointing down, and then the magnetic field due to 1 is going to be pointing up. So again, I'm going to call this distance x and see what I can get here. So again, I want the magnetic fields to be equal to each other. Magnetic field 1 is equal to magnetic field 2. I'm going to plug in the equations that we got last time. So mu naught times current 1 divided by 2 pi r1 is going to equal mu naught times current 2 divided by 2 pi r2. Again, mu naught cancels out and 2 pi cancels out. So, but once again, I could plug in 5a and 3a, but I need to, my big thing that I need to find out is what r1 is and what r2 is. So for r1, that's this distance here, like this. So this is r1. And R1, I can see is essentially, well, that's 2 plus 2, so it's 4 plus x. So it's 4 plus x. And then R2 is, well, this distance here, that's just x, right? Let me double check that. Yeah, it's just x. All right. And so now I can get I1, which is 5, over R1, which is 4 plus x. And then equals I2, which is 3, over R2, which is just x. So again, cross multiply, I'll get 5x equals 3 times 4 plus x. The 3 distributes, and I get 5x equals 12 plus 3x. Subtract 3x from both sides. That's 2x equals 12, or I get x equals 6. So I'm going to assume that's 6 meters. Is that all? Oh, it's 2 centimeters. Sorry. I'm going to assume 2 centimeters. I hope I didn't screw up that. Or 6 centimeters. Did I get those meters right as well? So 0.5 centimeters, I think, is going to be that answer there. And then this one here is going to be 6 centimeters. And let me really quickly just double check to make sure that my units didn't screw up here. So amps are going to cancel out. That's good. And then I'm left with centimeters left over. So I got lucky. I did not need to cancel out. So I think that is correct. It's going to be 6 centimeters and 0.5 centimeters. So, all right. Hope that helped. Yep. All right. Bye.